Sun Microsystems, a leader in visualization, announces new visualization workstations powered by its second-generation visualization accelerators, the VX and the MVX. This tape provides an interactive demonstration of the VX and MVX. Demos and Sun Vision tools are shown as they are running in volume rendering, image processing, 3D graphics, high-quality rendering, and movie loop display. Sun's visualization workstations are Sun Vision accelerators. Here, Sun Voxel, the volume rendering tool, is running on the multiprocessor MVX and the VX, which has a 32-bit true color frame buffer. Using Sun Voxel, one can interactively view data such as these CAT scan slices of a tree sloth as a 3D volume. Orthogonal cutting planes can be moved through the volume to reveal internal data. An arbitrary oblique cutting plane can also be used. The volume can be freely rotated. Sliders interactively control the speed and direction of rotation. This data set consists of 197 CT slices, each 128 by 128. In transparency mode, ray casting is used to render the volume with shaded colors and transparency. Here, a re-ray casting mode is used, which allows the user to interactively change the opacity values of substances in the volume, revealing internal structures in the data. A color editor can be used to easily change a substance's color. Here, the bone color is being modified by adjusting the red, green, and blue sliders. The substances are defined by the user according to ranges in voxel data values. In this example, skin, muscle, and bone substances were defined. A new volume rendering technique called splatting is used in this demo to render 96 CAT scan slices, each 256 by 256, of a human head. It is running on the MVX and VX accelerators. The algorithm, developed by Sun's Lee Westover while at the University of North Carolina, uses a forward mapping technique. The algorithm is described in Westover's paper titled Footprint Evaluation for Volume Rendering in the SIGGRAPH 90 conference proceedings. Sun Vision's image processing functions are greatly accelerated by Sun's visualization workstations. Here, the Sun IP tool is running on the MVX and the VX accelerators. Images with unlimited numbers of bands can be used in Sun IP. Here, 3 bands of a true color Landsat image of Boston are loaded into one of 6 Sun IP windows. This true color image is interactively rotated just by moving the rotation slider to any value between 0 and 360 degrees. The image can also be quickly scaled. Here, the 512 by 512 image is scaled up by a factor of 1.6 in X and Y. In this example, a 512 by 512 8-bit digitized photograph of a runway is loaded. Using the 2D FFT function in the Sun IP library, the log power spectrum is computed and displayed. Other transform functions included in Sun IP are 1D FFTs and transcendental functions such as sine, cosine, log, and square root. This 8-bit image of a brain scan can be interactively negated using one of the Sun IP arithmetic functions. Other arithmetic functions, such as add, subtract, and multiply, as well as logical functions, such as and, or, and exclusive or, are also available. Convolution filters, such as a 3x3 high-pass filter, can also be interactively computed and displayed. The convolution kernel can be interactively changed all the way from a unity gain to a high-pass filter and back. Sun IP accepts images with 8-bit integer, 16-bit signed integer, or 32-bit floating point values. Using the window level function in Sun IP, one can interactively display any sub-range of data values from an image containing 16-bit or 32-bit values. This is useful in enhancing different areas of the image. In this example, a range of values is specified in a 16-bit CT scan of a chest. This selected range of values is then scaled from 0 to 255. Several of the Sun IP library functions are used in this image roam demo, which is running on the VX. A large 3K by 4K 8-bit digitized photo is loaded into the VX memory. A subsampled version of the image is displayed. The original image data is displayed at full resolution in the viewing window as it moves. A convolution filter is now selected. The viewing window can still be moved interactively over the image. This is using a 3x3 convolution to implement a sharpening filter. The convolution kernel can be interactively set to adjust the sharpness of the image. A software bilinear zoom is selected next to enlarge the image in the viewing window by 2 times. In this demo, the zoom factor can be interactively changed from 1 to 10 times. Here, an FFT function is selected. The power spectrum of a 2D FFT is being interactively calculated and displayed as the viewing window is moved. Window level adjustment can be used to bring out contrast in the image. The lower and upper boundaries of the window are set with the slider, which can then be moved to the desired range. Again, this is being calculated interactively. Another way to enhance the image is with histogram equalization. Here, a local histogram is used. In this case, histogram equalization is being calculated over the 256 by 256 image in the viewing window. Alternatively, a global histogram can be used. Now the histogram equalization is being calculated over the entire image. Finally, let's focus in on this aircraft carrier. I'll select the global histogram and zoom functions, and then as I zoom in on the image, the number on the side of the aircraft carrier becomes visible.